This is Dr. Kavita Singh, Associate Professor in Department of Civil Engineering in Institute of Aeronautical Engineering. So today we are going to discuss a topic called as study of economic minerals like pyrite, hematite and magnetite. So these minerals are economically very much valuable in the society as well as in the industrial field. We have discussed already many minerals which are important in the construction industry as well as in the day-to-day life. So these minerals, what we are going to study today, these are important as an economic in sense as a economic point of view. These minerals are very important in the industrial point of view. So this will be discussing today. So let us start this lecture with this topic called as pyrite. So pyrite is a mineral. It's a kind of mineral which is very precious mineral. It's a very important mineral. It's very valuable mineral. Sometimes it looks like a gold. Basically, it looks like a gold. So pyrite is a mineral which looks like a gold. Basically, like a gold. Okay. So we call it as fool's gold. Like it's a false kind of gold, which we call it as fool's gold. So sometimes we extract gold also from this kind of mineral, and pyrite is FeS₂ and also known as fool's gold, and is a common iron sulfide mineral with a metallic luster and a pale brass yellow color. It is often mistaken for a gold. So as it looks like a gold, it is mistaken as a gold. Like it is like a gold, looks like a gold due to its similar appearance, but is much harder and more brittle. So as we see, gold is a somewhat soft compared to other kind of minerals, but this pyrite, it looks like a gold, but it's not soft like a gold. It is little bit harder and it's more brittle. It's easily it breaks off. And the general characteristics, if we see here, also known as fool's gold, due to its metallic luster and yellowish color. Okay, and chemical composition here is iron disulfide FeS₂, and hardness is 6 to 6.5 on the Mohs scale. So if you remember about hardness when we have studied in the previous lectures, hardness on the Mohs scale 6 to 6.5. This kind of hardness is like it's a harder kind of mineral. It's a very tough kind of mineral. And crystal system is isometric cubic, and the streak of this pyrite is black to greenish black. It looks like black to greenish black in color, and actually the mineral will be in yellow shade, but once you try the streak of this mineral, it will give you color of black to greenish black. So the powder form of this pyrite will be either black or greenish black color. So always remember, streak is the mineral which, when you make that mineral in a powder form, that mineral color we call it as streak color, and luster is metallic. It looks like a metal, and specific gravity is 4.9 to 5.2. Okay, so this is how it looks like it is like a gold. If you see the color and the shine and the look is like a metal, and it's like a gold, and it's very much precious mineral, and it's very much important mineral in the field of industry and in the daily use or any kind of commercial uses. So we'll see the economic importance of these kind of mineral. So economic importance here is sulfur source. So pyrite is a primary source of sulfur and sulfuric acid production. So pyrite extraction will help us to extract the sulfur and sulfuric acid from this pyrite. And gold extraction, some pyrite contains microscopic gold and is processed for the gold recovery. So industrial use used in the production of iron sulfide, sulfur dioxide for the chemical industry. And environmental impact. So what is the environmental impact here is, when exposed to the air and water, pyrite can cause acid mine drainage and a major to the environment. Now, what are the uses and the applications of pyrite we see? So, what are the industrial uses here? So, used in the sulfuric acid production as a source of iron, and gold extraction sometimes contains small amount of gold which can be extracted through the processing. Collector specimens due to its cubic and octahedral crystal habit. It's valued by the mineral collectors. What is the environmental impact? If we see, can lead to acid mine drainage when exposed to oxygen and water, forming the sulfuric acid and the iron oxides. Occurrence here is found in the hydrothermal veins and coal beds and sedimentary rocks and igneous intrusions, common in association with the quartz and chalcopyrite and sphalerite and concerned in mining. And next thing, we are going to discuss here is hematite. So hematite is also a mineral which is economically very much useful here. So hematite is a Fe₂O₃ is a widely used in the mineral with the applications in various industries due to its high iron content. So hematite is having a high iron content present in that, magnetic properties and durability here. And the general characteristics, if we see of hematite here is, so it's a major iron ore mineral with a high content and chemical composition. So iron oxide Fe₂O₃, and the hardness of this hematite is 5.5 to 6.5. Now 5.5 to 6.5 on the Mohs scale, this kind of hardness is also a harder kind of mineral. When you compare with the other soft minerals, this mineral is also harder mineral, and even it contains more kind of metal here, like iron content is more here. That's the reason it is harder. And crystal system is hexagonal, and the streak of this hematite is reddish brown. So streak of this hematite is reddish brown. The reason here is because of the more iron content in the hematite. It has the color of reddish brown color. When you try to streak on the streak plate, you may find the color as reddish brown. Or if you make this hematite in a powder form, so the powder form of these hematite will be reddish brown color. So what is a luster here? Luster is metallic to earthy. So the shine of these hematite mineral is either it looks metallic or sometimes it looks as a earthy in color. So specific gravity here is 4.9 to 5.3. Now this is how the hematite it looks like when you see. So if you see here, some places you may find it looks like a metallic structure. Now here you can see it looks like a somewhat like a earthy color. So because of the iron content, even you can see the color here is somewhat reddish brown in color. It is looking like. And metallurgical application. If you talk about the applications here, so these are the applications. When you talk about the applications here, we have some metallurgical applications like iron ore or steel production. Hematite is a major source of iron used in steel making. It's a major source of iron. It is used in the steel making industry. It is processed in blast furnaces to extract the iron, which is then used in construction and automotive manufacturing industries. And pig iron and alloys. Hematite is used in the production of pig iron, which is further refined into steel and cast iron. Construction and infrastructure. Concrete and heavyweight aggregates. Due to its high density, hematite is used as an aggregate in the concrete to provide the radiation shielding in the nuclear reactors and hospitals. Road construction used as a stabilizing agent in the road construction, and particularly in the areas where the strength and durability are required. So this is also used in the road construction. Now pigments and coatings, if we talk about pigments and coatings. So red pigments, hematite is used as a natural red pigments in paints, ceramics, coatings due to its deep red or rust color. Now corrosion protection, if we see corrosion protection, it is used in the protective coatings for metals to prevent the rusting. Electronics and magnetic materials, hematites weak magnetic properties make it useful in certain electronic applications and as a component in the ferrites. Now semiconductors, as a semiconductors, it is used in a research, photocatalysis and solar energy applications too. And if you talk about jewelry and ornaments, so it is having application in the jewelry and the ornaments also, like beads and carvings. So hematite is a polished and used in the jewelry, including the bracelets and the pendants. So including the bracelets and the pendants, so it is used as a jewelry to make the pendant, and healing and metaphysical uses believed to have a grounding and protective properties in alternative medicines. So it also works as a alternative medicines for healing the metaphysical activities, like it is used as a metaphysical activities, and it is believed that it is to have a grounding and protective properties as alternative medicines. Now, environmental and industrial uses. If you talk about the environmental and industrial uses here, so water treatment used in the filters to remove the heavy metals from the wastewater. It is also used as a content or a chemical or a, we can say, a mineral which will help the water to be treated or to be filtered and to be remove the heavy metals from the wastewater. Catalysts in the chemical reactions act as a catalyst in the various chemical processes, including the ammonia synthesis. Now, glass and ceramics. So glass polishing. So finally ground hematite is used. Finely ground hematite is used as an abrasive for polishing the glass and the optical lens. So it is used to polishing the glass and the optical lens. Ceramic glazes provides a red-brown coloration and ceramic glazes. So it provides a red or brown coloration in the ceramic glazes. And if you talk about the oil and gas industry, so drilling fluids. So hematite is used as a weighing agent in drilling fluids for oil and gas wells, improving the stability and reducing the pressure imbalances. Now, if you talk about the economic importance here, so as it is an economic mineral, so it is having the economic importance here. So iron ore, one of the most important iron ores used in the steel production. So it's very valuable and it's having a very wide application here because it is used in the steel production. Steel is widely used in the industrial fields, and the pigments here is used in the red or for the paints and the coatings. Now, jewelry and ornaments here, polished hematite is used for the decorative stones and magnetic bracelets. Radiation shielding used in the nuclear industry to block the radiation. So this is used in the nuclear industry to block the radiation. So what is the occurrence here? So commonly found in the banded iron formations, sedimentary deposits and metamorphic rocks, often associated with the magnetite, quartz and geotite. Now, hematite extraction process. So it has a huge extraction process. In a stepwise, the hematite is extracted here. So mining of hematite. So hematite is mainly extracted through the open pit. So there will be open pit from where the hematite is extracted, or underground mining, depending on its depth and the location. So depending on the depth of the location, the type of processing, the type of mining process is decided here. So open pit mining here is used for the shallow deposits. Whenever you have a shallow deposits of hematite, so we use the open pit mining. Large scale excavation with a heavy machinery it is done. Now, underground mining is used for the deeper deposits. So wherever we find deep deposits or deeper deposits involves in the tunnels and the shaft, so there we go with this underground mining, and for the shallow deposits we go with the open pit mining. So this two type of mining is done for the hematite here. Now, crushing and grinding. So this is the first step. This is the second step here. Second step in that we crushing and grinding of this hematite. So the mined ore is crushed into smaller pieces using the crushers, like we use jaw crushers, cone crushers, and the crushed ore is then ground in a ball, mills to a fine powder to increase the surface area of the beneficiation. Now, what is the beneficiation here is the process of treating. So beneficiation here is the process of treating the raw materials to improve their physical and chemical properties. Now, third step here is, this is the third step we follow. What is that? Beneficiation. So ore concentration. So the hematite ore is purified through different beneficiation techniques. Now, under the beneficiation techniques, we have again different techniques, like we have the gravity separations, we have the magnetic separation, and we have the flotation method. Now, what is let us understand what is the gravity separation here in the beneficiation. So, used when the hematite ore is coarse grained. So, coarse grained. So, methods include jigging, spirals, shaking tables, and dense media separation. So, they use the shaking and the movement of the table, or they use a jigging method, and this method a method used to concentrate hematite ore, utilizing the difference in density between the heavier hematite particles and lighter impurities by flowing a powdered ore mixture through a stream of water, allowing this denser hematite to settle while the lighter particles are washed away. So in this method, the lighter particles will be washed away and the heavy particles will be settled down in the gravity method. Now, magnetic separation here. So since hematite is weakly magnetic, so strong high intensity magnetic separators are used. So here strong magnetic high intensity magnetic separators are used. So this removes non-magnetic impurities. So this is a process where hematite is weakly magnetic. Iron ore is separated from other minerals in an ore mixture by using the magnetic field. So allowing this magnetic hematite particles to be attracted to a magnet while non-magnetic impurities are left behind. Now, third thing is flotation here. So, beneficiation methods, separation of the hematite here. So, in the flotation method for fine grained hematite, the ore is mixed with a reagent. So, in this flotation method, so the ore will be mixed in a reagent like collectors and frothers to create froth, which selectively separates the hematite from the impurities. Now, the iron-bearing mineral hematite is separated from the gauge minerals, usually quartz, by selectively attaching to air bubbles in a slurry, allowing the hematite particles to float the surface and be collected as a concentrate, while the unwanted minerals remain in the liquid phase. Now, the fifth method here is step. If we see here, this is the step 3. Now, next step here is smelting in a blast furnace. So the concentrated iron ore hematite is mixed with a coke or carbon and limestone, and the mixture is fed into the blast furnace where hot air is blown in. And the sixth method here is further refining. So the crude iron from the furnace is that we call as pig iron is further refined in steel making process, and we have our electric arc furnace, and this removes the carbon and impurities to produce a steel. Now the third economic iron here is magnetite. So magnetite is Fe₃O₄. So magnetite is naturally occurring iron oxide, has a various applications due to its magnetic properties, high iron content, chemical stability. So if you talk about the general characteristics here, so general characteristics here is strongly magnetic mineral. Hence the name itself is a strongly magnetic mineral. That means it has a strong magnet in this kind of mineral. Now, chemical composition is iron oxide. Hardness here is 5.5 to 6.5. That means on a Mohs scale, this is also having the more hardness. Now, crystal system is isometric and the streak here is black. So, when you make this magnetite mineral into the powder form, so this mineral will become black in color. So, luster here is metallic and specific gravity is 5.2. Now here, this is the figure you can see here having the metallic look here. Luster means it is a shiny, and in the powder form, if you see, the streak of this will be black in color. Now, metallurgical applications, when you talk about the applications, so iron ore for steel production. So magnetite is a source of iron used in the steel manufacturing, and it is processed in the blast furnace or direct reduction plants to extract iron. Pelletization. Magnetite concentrates are used to produce the iron ore pellets, which are more efficient in the blast furnaces, and foundry industry used in the cast iron production due to its high iron content. Magnetic and electrical applications. So here, magnetic storage media used in the magnetic tapes. This magnetite is used in the magnetic tapes. It is used in the floppy disk and in the hard drives. And magnetite nanoparticles applied in data storage, catalysts, and biomedical imaging, MRI, contrast agents, electromagnets, and transformers used in ferrite cores or for the electronic components. So as it has a magnetic property, so it is used in the tapes, floppy, and hard disk drives. Now, environmental and industrial uses. So water treatment using the filtration system to remove the heavy metals and in other contaminants. Catalyst and chemical reactions plays a role in hydrogen production and desulfurization process. Now, a heavyweight concrete used in the radiation shielding for the nuclear reactors, hospitals, and the laboratories. And coal washing magnetite is used in the dense media separation to separate the coal from the impurities. And the biomedical applications, it has even a biomedical applications like in MRI contrast agent, magnetite nanoparticles enhance magnetite resonance imaging. So it is used in the MRI, in the biomedical applications, drug delivery systems used in the targeted drug delivery and cancer treatment. Even it is used in the cancer treatment via hyperthermia therapy, and bioseparation helps in the cell sorting and the protein purification. Now, if you talk about energy and renewable applications, here, catalyst in the fuel cells. So used in the hydrogen production and energy storage, solar energy. Research shows potential photocatalyst for the water splitting, and magnetite slurries used in the thermal storage systems for the solar power plants, and constructions and abrasives. So road construction used as an aggregate in the asphalts and road-based materials, and abrasive series. Finally, ground magnetite is used in sandblasting in the polishing. So it is also used in the construction field as a abrasives for sandblasting, for polishing, or as a road-based material. Now, economic importance has its economic minerals. What is the main economic importance here is, as an iron ore along with the hematite, magnetite is a major ore for the steel production. Magnetism used in the magnetic storage media, electromagnets, and MRI machines. Heavy media separation used as a coal washing to separate the valuable minerals, and as a catalyst. So used in industrial catalyst and wastewater treatment. So industrial catalyst and wastewater treatment. And occurrence here is found in igneous, metamorphic, and sedimentary rocks. So these magnetites are found in the igneous rocks, metamorphic rocks, and sedimentary rocks. So common in banded iron formations, skarns, and magmatic intrusions. So it is commonly found in the banded iron formations, where you can find the banded layers in the rocks and even in the magmatic intrusions associated with the hematite, pyrite, and serpentine minerals. Now, conclusion here is hematite and magnetite are the primary iron ores and crucial for the global steel production. So, both hematite and magnetite. So, these are the most important primary iron ores which are used for the global steel production. And pyrite, although not an iron ore, is important in the sulfuric acid production and occasionally in the gold mining. So the presence of these minerals in the geological formations helps in identifying the potential mining sites and economic deposits here. Okay, so let us conclude the session here. So these are the references you can just go through to find out the more content. If you want to go through the more information about it, just go through this textbook like Keshavlu and Chenna and Venkat Reddy or Vasudev Keniti you have. These are books you can just go through to find out the more content about this pyrite, hematite, and magnetite. So that's all for today. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.